A warm welcome to another episode of SciencePunk Explains the Frame Budget Approach. Today, we are diving back in to tackle a huge question. What does it really mean to measure something?
So, in the last episode, we established that real systems are pretty much never perfectly isolated. They're always interacting. And that brings us to the next big question. When a system measures something or is being measured itself, what actually becomes visible in that process? And crucially, what does that visibility cost?
Okay, let's dive into this with a simple, everyday example. Imagine you want to measure the temperature of a small cup of tea. Seems easy enough, right? You just stick a thermometer in and read the number. But is that really all that's happening? Are you just passively looking? We tend to think of measurement as this completely neutral, passive act of just, looking. But the frame budget approach shows us there's a much more active and, frankly, a much more interesting process going on under the hood. So here's the big shift in thinking we need to make. The naive view, the one we all kind of start with, is that measurement is just passive looking. You're like a spectator watching a play. But the FBA view says, nope. Measurement is always an active physical interaction. You aren't just watching the play from the audience, you've actually stepped onto the stage. And this is where we get to a really cool concept called back reaction. See, to measure the tea's temperature, your thermometer has to physically interact with it. It has to absorb a tiny little bit of heat energy to make its reading go up. And by doing that, it has ever so slightly but definitely measurably cooled the tea down. The bottom line, every single active measurement changes the system it's measuring. It's never a free lunch. It's never a totally innocent action. This really just nails it, doesn't it? The act of observing is a real physical coupling between your tool and the system. It's a two-way street. The tea affects the thermometer for sure, but the thermometer also affects the tea. So, let's build on that. If measurement is an interaction, a real physical coupling, then what exactly does it let us see? What information do we actually get access to? Well, think about it. Is that thermometer all-seeing when it comes to that cup of tea? Absolutely not. It gives you one specific piece of information, the average kinetic energy of all the water molecules, which is what we call temperature. But it is completely blind to, say, the exact position or the momentum of any single one of those molecules. In the frame budget approach, these specific routes of access are called channels. And a channel isn't some metaphor. It's the actual physical pathway that allows one system to get information about another. So visibility isn't total, it's operational. You can only see what you have a physical channel to access.
And this is where the idea of calibration becomes so incredibly important. Now, what this is really saying is that what we're able to measure is defined entirely by our tools and how we use them. Calibration is basically the bridge that connects an abstract idea, like time or length, to a real physical procedure, like the ticking of a clock or the marks on a ruler. Our tools don't just reveal a pre-existing reality, they help define what is even measurable for us in the first place.
And this whole process reveals hard physical limits. It sets what the FBA calls a front bound, which is basically a speed limit on how fast information from an interaction can travel. You can think of it as the operational origin of something like the speed of light in this framework. So the big takeaway here is that what becomes visible to us is never the whole of reality. It's just an operationally accessible slice of it, a slice that's defined by our channels and our calibrations.
Okay, so this leads to a really fascinating kind of mind-bending consequence for how we even define the system we think we're looking at. The lines, it turns out, aren't as clear as they might seem. Let's just walk through this. At first, you think your system is simply the cup of tea, but then you go to measure it, so you insert the thermometer. Now, because of that interaction, that back reaction we just talked about, if you want to do the physics correctly, your effective system isn't just the tea anymore. It's now the combined tea plus thermometer system. The boundary you use for your counting has literally expanded. And I want to be really clear. This is not just some conceptual trick to make the math work out. It's a description of the physical reality of what happens when things couple together. The moment you start to measure something, your tool becomes a functional part of the system itself. And there's more. This interaction doesn't just happen and then, poof, vanish without a trace. It leaves behind an inscription, a physical record. The final reading on that thermometer's display, that's a physical inscription. It's the lasting evidence, etched into the world, that a measurement interaction actually took place. Okay, now for the final turn. Let's take all of these powerful ideas, measurement as a real interaction, visibility being limited to physical channels, and these shifting boundaries and apply them to one of the deepest questions of all. I mean, seriously, if just measuring a simple cup of tea involves all this physical complexity, what in the world does it mean for a system to know its own state? Can you or any complex system have perfect, complete, and instantaneous knowledge of yourself? The frame budget approach offers a pretty radical and very physically grounded answer. And it's this: self-access, a system knowing itself, is not some special, magical process. It doesn't get a free pass. It has to obey the exact same physical rules as any other measurement.
And just think about the consequences here. For a system to know itself, it has to have real, physical, internal channels to get that information. And that process of self-measurement, well, it's going to have an internal back reaction, changing the very state it's trying to measure. It's going to cost resources or budgets. And because of all this, knowledge of one's own state can never be total or instantaneous. It's fundamentally limited by real physical pathways and processing delays.
And this, right here, is the ultimate reframing of the problem. Self-knowledge gets demystified. It's no longer about some philosophical inner magic. It becomes a real, physical question of access, back reaction, and the reconstruction of information from limited internal channels. So, let's bring it all home. What are the crucial points to take away? First, measurement is never just a passive glance. It is an active, physical interaction with real costs and real consequences. Second, visibility is always limited. What any system can see about the world or itself is defined by its physical channels and its operational boundaries. And third, these same rules apply to self-knowledge. It's a physical process, it's constrained by physics, and therefore it is never total or instantaneous.
In the next episode, our season finale, we're going to bring this whole journey together. We'll connect all the dots and ask a very important question. What has the frame budget approach actually given us so far in concrete terms? You won't want to miss it. Bye for now, until the next episode, and stay curious.